Hey guys, Mr. B here again, bringing you another math video. This one part of the calculus videos that I've been making lately on the product rule. So in your calculus classes, probably you've done some of the, I won't call them simple because there's nothing simple about calculus, but some of the lower rules, like probably the power rule, the constant multiple rule, sum and difference rules, and things like that. And now you've started to move in some to the more complicated stuff. And you probably start it with the product rule. So what I'm going to do in this video is very simple. I'm just going to give you just basically what is the product rule, and I'm going to give you the proof of the product rule. And then the next video that I'll make after this will give you 4 or 5 examples of using the product rule. So one of the expectations that I have for my students in calculus class, and pretty much any first year university class calculus, will be an expectation that you can prove the product rule. So that's basically what I'm going to take you through in this video. Alright, so the product rule is basically used for finding the derivatives of functions that consist of 2 or more functions multiplied together. So if you look at this example right here that I have, well, just this general example, our function y consists of a function f multiplied by a function g. So, you know, these functions could be anything. F might be a linear function, x plus 5, and g of x might be a trig function, sine of x. Or f of x might be an exponential function, 2 to the x, and g of x might be a quadratic. So there's lots of different variations on when you use it. But the most important thing about derivative rules in general is recognizing when do you have to use that particular rule. And you have to use the product rule when you have 2 or more functions that are multiplied together. And when that occurs, the derivative of that particular function consists of this. So y prime, and in that case my y is equal to f times g. So the derivative of f times g is y prime, and it is f times the derivative of g, g prime, plus the derivative of f, f prime, times g. So that there is the product rule. That's the way I like to remember it. So it's a lot easier to remember in this notation than it is with all the d over dx and then the derivative and notation f of x and all that stuff. So this is the easiest way I think to remember it. Alright, so now on with proof. So one of the things that I remember when I first did calculus, and I remember sitting in my university class with 100 students sitting around you, and the prof does this proof of the product rule, and he pulls out all these techniques, and they'll call it, I remember him saying there's only 2 real things you can do in math, which is multiply by 1 or subtract by 0 and things like that. And I remember asking him, well, how do you know when you do this, or how do you know when you have to do a certain technique? And I remember his answer was one word: intuition. And to me, that was just a complete crock of poo. There's, like I say to my students, it's really easy for me to get up and do the proof of the product rule because I've done it. I learned it when I was in school. I've done it for students hundreds of times. So yeah, it looks easy when I do it. But if you want to learn a proof of the derivative, you have to sit down and work through it. So that's why your prof knows it, because they've done it hundreds of times. I can guarantee you, I've sat in math class with students who've gone on to be math profs and doctorates of math, and they didn't know the product rule the first time they did it, and similar to you. So you just have to sit there, you have to go through it, and think about what technique gets you what proof. So the product rule is no different. So I know people are out there, just get on with the proof. Alright, so here we go. So just like the majority of your proofs that you'll do in math and calculus, they all go through the definition of derivative. So I'm just going to write out the definition of derivative. And first of all, I'm going to write over here what my function is. So my function that we're trying to find the derivative of is f of x times g of x. So sorry, I apologize for my writing. It's not the greatest. Alright, so I am on Christmas break as well, so I mean I'm totally rusty. Alright, so let's give this a shot now. So the definition of derivative is y prime. Most often you'll see that probably as f prime. But I'm using y prime just simply because we have f's already in the the definition here. So I have the limit as h goes to 0, and then I'll write out the typical definition, which is f of x plus h minus f of x all over h. Now it always makes me a little nervous when I do that because I don't want you to get confused. This f right here is totally different than this f. So what I mean by that is that this f could be anything. It's could mean f of x times g of x, for example. And so this f could be anything, but this f is specific, if I can say that word correctly, to this question. So when I write out what this function is for my definition of derivative, well, my function is f of x times g of x. Now, I could have probably easily solved that by changing this letter. I just don't like to sway from what I know as my definition of derivative is always exactly the same. Now, one way you could get around it, and it's too late for me now, is change it to a capital F or something like that. All right, so my definition of derivative for this specific function, where my function is f of x times g of x. So what I need to do is I need to put that x plus h where I see an x in my function. So I see it right there, and I see it right there. So to end up with f of x plus h times g of x plus h. There you go, minus, and then you got your f of x here, and then f of x times g of x. So that's f of x is this entire function right here, all divided by h. All right, so this is where we reach a point. What do we do? So it's one of those things, guys. I just know it. That's pretty much because I've done it. If I was sitting here trying to prove a derivative rule that I've never seen before in my life, I would probably have to try 5 or 10 different techniques until I got one to actually work. Now you might, for those of us who have a lot more education than I do, might be able to see that a new derivative rule they've never seen before and prove it instantly. I don't know, maybe they can. But for the regular guys like me, or a regular student like you guys just trying to get through calculus class. Now I have a math degree and education degree as well, but for the regular student just trying to get their calculus course so they can get whatever degree they want, really we don't care. All we want to do is know how to prove the product rule. So the technique that we use is we have to use this guy. So we have to add and subtract f of x plus h times g of x. So what we're going to do is I'm going to throw this guy right in the middle here, and hopefully we can get something good to work out here. So let's give it a shot. So the limit as h goes to 0 of f of x plus h times g of x plus h. So then I'm going to change the color of my marker, and I'm going to add in this. I'm going to subtract it first. F of x plus h times g of x. And then I'm going to add it. F of x plus h times g of x. Just right there. And then I'm just going to throw back this guy right here to the end part. So minus f of x times g of x, just like that, all over h. So this is the part where my prof said intuition told him that he had to do that, which is complete crock. What tells you have to do that is because you've practiced the proof. You've done it. You've practiced it before you got into the test. There's only a finite number of proofs calculus prof can ask you, and product rule, I'm sure, is one of the most frequently asked ones. So how do you know you have to do that? Because you've done it before on your own at home. So this is what you need to put in your little back pocket and make sure you know how to when you do the proof the product rule, that's what you're adding in. Alright, so now the next step is we try and simplify this as much as possible. So what I'm going to do is I'm just going to chunk this into two parts. So I'm going to chunk it into this first two terms divided by h, and these last two terms divided by h. So this is what I get. So f of x plus h, g of x plus h, bracket, minus f of x plus h times g of x, all divided by h. And then I'll separate that with a plus sign, limit as h goes to 0 of all this guy now divided by h, minus f of x, g of x, all divided by h. Alright, so now my next step is to try and basically get two definitions of derivatives in terms of f and in terms of g. So if I look here, I have a common factor of x plus h in this guy, so I'm going to take that guy out, and then I have a common factor of g of x in this guy. So if I look what's left behind, I'm left behind with g of x plus h minus g of x, and I'm left behind with f of x plus h minus f of x. So it had to be, that's what I'm shooting for. I'm shooting for definitions of derivatives within them. And I need two, because in my product rule, if you look here, I have a g prime and an f prime. So those are definitions of derivative in terms of g for g prime and in terms of f for f prime. So let's take out, so limit as h goes to 0. So I'm taking f of x plus h here, just like that. And in brackets here, I'm going to leave my h in here too as well. G of x plus h minus g of x all over h. So there you go. Definition of derivative in terms of g. And then I had the limit of h approaches 0. That's a 0 there, guys. I don't know what that's supposed to be. Take out a g of x here. Take out my g of x in big brackets. F of x plus h minus f of x all over h. So there I have it. I have two definitions of derivative, one in terms of g, one in terms of f. So now what I do, I'm just gonna basically distribute my limit a little bit better. So I'm gonna put my limit to my f of x plus h, then my limit to my g of x, this guy right here, my definition derivative in terms of g. Then I'll do my limit to the g of x and limit to this guy. So I really want to do that, especially if I'm in a test situation. I want to show the prof, I understand this proof. I know what I have to do. I'm just not all of a sudden jumping to the last step because I know what the product rule is. I want to show him every step along the way, very, deliberately, the kind of thing, right? So I know I've been in university. I did the first year courses. I got a math degree. It's sometimes very frustrating the way that profs mark, but you don't want to give them any excuse to take marks off because they're looking for it. So make sure you do, especially when one like this, you know what's coming. You got to make sure you're ready for it. There we go. So there's the limit distributed to each one. So now if I basically just have to take the limit at each one of these situations. So if I look here, the limit of f of x plus h, so that says h goes to 0. So this h is essentially 0. So what I get left with is f of x, right? And then this guy right here is my limit as h goes to 0 of g of x plus h minus g of x all over h. So that is the definition of derivative in terms of g. So that's going to be g prime of x. And then this guy right here, the limit as h goes to 0 of g of x, there's no h in g of x, so that's just going to be g of x. And then my limit as h goes to 0 of f of x plus h minus f of x all over h. So that's the definition of derivative in terms of f. So that's f prime of x. So essentially what we have is f times g prime plus, now this is reversed order, but that makes it no difference, g times f prime. And if you're not comfortable with changing up your derivative rule, we can do it f times g prime plus f prime times g, and that's it. She's done. So there it is, guys. That's the the proof of the product rule. I know your pain, but just know it. Good luck, and if worse comes to worse, you're stuck the night before the test, I would never say this in class, but memorize that bad boy, because it's better to memorize it and do well on the test. You can figure it out after. So good luck. Check out my other videos. See you guys in class hopefully, and good luck.